Hello everyone, I'm Stephen Adams, and today I'd like to talk about problem solving as a skill that you can learn. I think a lot of people out there think that problem solving is a gift or a talent, so if you aren't one of those lucky people who got that, then you just missed out on the genetic lottery. I want to be open to the thought that it is a skill that can be practiced and learned. Some people with a talent for it might have a head start, but we can catch up to those people. To start off, it's good to agree on what I mean by the words problem solving, since we use the phrase so commonplace in our normal speech. For us, problem solving is going to be a process of finding solutions to difficult or complex issues. We have to take action to try to search for that result that we're trying to find. It's an active thing that we have to work at. It's not passive. We can't just sit back and stare at the page until the answer pops up for us. Notice that the words complex and difficult have very different meanings. Complex simply means consisting of many interconnecting parts. These kind of problems that we want to solve are often complex, but that by itself does not make them difficult. Let's discuss 5 strategies for problem solving: trial and error, abstraction, analogy, decomposition, and lateral thinking. We'll follow up with an example that you can try and see how these different problem solving techniques come together. Does it surprise you that I'm presenting trial and error as a valid problem-solving technique? It is. It just isn't a particularly efficient one. You don't even know if you'll ever find an answer at all. In the absence of any idea what to do, this is what some of us do. Just pick something and give it a try. The rest of us sit and stare at it until it goes away. No, of course not. We try something else. When we're using trial and error, we're trying to find some clue that might allow us to employ another, more efficient technique. Sometimes we're very lucky and we make a great guess and come up with something very insightful right off the bat. More often we don't get very far. Using trial and error, it's important to keep track of what you've tried so that you don't end up repeating the same ideas over and over again. Another really critical part of effectively using trial and error is stopping and evaluating whether you have actually answered what is being asked. The second strategy that we're going to discuss is called abstraction, and it involves trying to solve the problem in a model before trying the real problem. A model is just a reduced detailed version of your problem. Instead of taking on the entire problem with all of its details, you try to learn something about what the solution will look like with some of the details taken away. If you wanted to model traffic flow, you probably wouldn't start out by adding pedestrian crosswalks and yellow lights and people running lights and all kinds of other things. You would just start with 2 roads that cross each other. You have red lights, you have green lights, and you would start from there. Instead of trying to write a program while we're learning how to speak in Python and practicing solving problems at the same time, we're going to use 2 major kinds of models in this course. The first one is called an IPO chart, which stands for Input, Processing, Output. It's a way of breaking problems up. We're also going to look at flowcharts, which is going to model for us the order that computers will run our programs in. There's many different kinds of visualizations that you can use. These are 2 that we find effective here. In an example that you'll see soon, the spy in the rust-colored trench coat, I use a small chart to keep track of my details, and that's a good enough visualization to help me solve that problem. In Buckner's Boardwalk, I'm going to use a different kind of grid to try to keep track of all of the different implications that are coming out of the clues. And again, It's a different visualization, but it's a good tool for what I'm trying to achieve. Models are not one size fits all. Becoming good at picking which kind of model and what techniques to use is a challenge in and of itself. The next strategy that we're going to employ is called analogy. And what analogy is relying on your past experiences to give you some hints at how to solve a new problem. So this is one of those strategies that gets people encouraging you to solve a lot of different kinds of puzzles and to work on lots of different kinds of problems. When we look at logic puzzles, we can see similarities between those and the game of Sudoku. Some tip we know about what to do there when there's only two numbers in a row left could apply to a totally different situation, like trying to figure out who brought a car to a garage on a certain day. We will practice looking for implications and applying deductions to one type of problem, and then we can use that technique to solve other problems. This strategy is all about recognizing that some part of your current problem is similar in structure to another problem. And that because you figured out this problem before, those parts of the solution that you can modify can be reused in a new problem that you have. It's not about memorizing a bunch of different solutions to problems. The details will kill you. But it's about looking for techniques that you can generalize and apply to many different situations. The next technique is called decomposition, and it's sometimes called divide and conquer. You have some big problem that you don't know how to solve. But somewhere in that problem's description, you find a small part of that and you think, hey, I know how to solve that little piece. Well, that's the essence of decomposition. Software development in particular benefits from this approach because those small pieces that you've identified can be generalized and be reused over and over again in many different pieces of software. This leads to modular design, and that's a very natural way to build software. Reusing already written software pieces leads to great amounts of efficiency, even if you only consider just the time typing things in, never mind figuring them out. There are huge libraries that you might have heard about. If you play video games, you might have heard of Unity. Windows users might be familiar with .NET or with DirectX. These are libraries that give you tested, high-performing code to build your own applications on without you having to create any of it. Python has a number of well-supported libraries for machine learning, for artificial intelligence, graphics drawing, and many other things that can be downloaded free. The next technique is called lateral thinking, and strong lateral thinkers are sometimes thought of as miracle workers. Lateral thinking involves thinking about a problem from an unexpected point of view and reaching some equally unexpected insight or solution. This is a hard strategy to intentionally practice because it is about being a creative thinker. Brain teasers and plays on words are great ways to start understanding this kind of thinking. For example, if a father and a son are in a car accident and the father dies, the son is seriously injured and he's taken to a hospital. The doctor comes in and says, I cannot operate on this boy, he's my son. How is that possible if the father died in the car wreck? Pause if you need to think about it. I bet you some of you came up instantly with the answer, well, the doctor is his mother. But you see, if you were thinking about that from a point of view where you thought that doctors are male, then you would have a very hard time trying to puzzle out the solution to this. That little shift of thought made the entire problem very simple. Having considered all these problem-solving techniques, it's important to realize that it's all tied together with critical thinking. You're being asked to question what you're doing and how you're doing it. You have to analyze and evaluate the information that's put in front of you to form a judgment. You have to judge not only what's being asked, judge what information is available and relevant, but you also have to judge whether the problem's valid at all. Maybe there is no solution to something, and that's something you have to reach. You'll also have to spend time considering whether or not, after you've reached a conclusion, did you answer the question that was asked? When it comes to software, this is very important, and it leads to a whole practice called software testing. In this lesson, you've opened the door to understanding that problem solving isn't something that some people are born with and that's it. You've seen it as a skill that you can practice and learn. It's something that if you don't think you're good at, you can practice by starting with simple problems and building your way up to the more difficult ones. Most importantly, it's a skill that has nothing to do with computers. These are skills that are about you, your mind, and how you perceive problems and how you reason your way through them. You can apply these skills to anything from evaluating the validity of a post on social media to figuring out how to get to an exam if your car breaks down. I presented you with 5 strategies for problem solving, and there are many, many more. I've introduced the models that we're going to use in this course so that you can understand that they're a part of our problem solving techniques. Hopefully you're going to find the puzzle examples interesting, and I look forward to hearing from some of you on what you came up with. I'm Stephen Adams, and I hope you are having a great day. Bye for now.